One more parameter in calculating execution time is, number of instructions. Okay. So example, let's say you know the number of instructions of a program, then we can compute execution time, and this is a formula. Execution time in cycles equal to number of here clock cycles. Okay. Number of instructions per a program into average clock cycles per instruction. Assume that, let's say, you know the average clock cycles per instruction. So example, let's say, did you remember in pipelining we have seen that our stages are designed such a way that each stage typically takes one cycle for any instruction, correct? Now second thing, because it is parallel execution, on average every instruction was taking one clock cycle. So at that moment I can say that in this model each instruction on average taking one clock cycle. That means clock cycles per instruction in this pipelining model is 1, right? So sometimes what happens, maybe the design might be different than which we have discussed, so on average instructions might take more time. Example, let's say branch instructions. If you have branch instructions, then there is a penalty. Because of the penalty, so rather than 1, so maybe 20% of the instructions are branch, then probably the penalty will introduce more CPI, correct? That means because of that your CPI will become 2 or 3, depends. Like I don't want to say that it's exactly 2 or 3, but it will vary. So that is the way CPI will vary, right? If the pipeline is going full-fledged, CPI for instruction is 1. Now if I change the architecture so that one instruction is taking 3 clock cycles, another instruction is taking 4, then average will be different, right? So there are various different ways we can change the clock cycles per instruction. Assume that, let's say, it is given average clock cycles per instruction and number of instructions, then if you want to know the execution time of a program in number of clock cycles, okay, so answer is number of instructions per a program into average clock cycles per instruction. If you want to know the execution time in seconds, then multiply this one with, because you get answer in cycles, then you multiply it with each clock cycle, 1 clock cycle, correct? Now let us see one problem related to that. Suppose we have 2 implementations of the same instruction set architecture. There is one instruction set architecture, okay? So same means what? Example, let's say instruction set architecture is fixed, then you will be having load, store. Assume that, let's say, you have one instruction set architecture, it contains load, store, add, okay, maybe subtract, whatever. You are not changing the instruction set architecture means what? Both programs are having same kind of machine, and that's why same kind of architecture, understand? Now that is what given. Suppose we have 2 implementations of the same instruction set, but implementations are different. So there is a computer A, computer B. Computer A is implementing instruction set architecture in one way, B is implementing in another way. Sir, what does it mean? Maybe computer A is using a pipelining model. Maybe computer A is using, of course, nowadays every computer uses pipeline model. So computer A is using, executing load instruction with 4 stages. Okay, I don't know why. So computer B is taking 5 stages for every instruction. Then we say that instruction set is same, load is same, but A computer is taking 4 stages, B computer is taking 5 stages. Such a way they have been implemented. It's up to the designers, understand? So sometimes, so now modern architectures like modern Intel architectures, like they use 13 to 30, these many stages, understand? So that's why, so whatever we are studying in theory might not be exactly same in the reality, understand? So whatever, finally one instruction set architecture is implemented in different ways. That's why, so that will affect the values. Example, let's say one load instruction is implemented in one way, okay, first way. Because of that, maybe the load instruction might take 2 clock cycles, maybe 3 clock cycles. Maybe in another implementation, same load might take 5 clock cycles. It's, up to the implementation, right? That is what the meaning of implementations. So there are 2 different implementations. Computer A has clock cycle time of 250 picoseconds. Try to remember. So we have 2 computers, computer A, computer B. So when this instruction set is implemented, then in that computer the clock cycle time is 250 picosecond. We will note down. Pico means 10 to the power of minus 12 seconds, right? Now B, computer B is using 500 and one more thing, clock cycles per instruction is given, right? So average clock cycles per instruction is 2.0. Here CPI is 2.0 for each instruction. Second one, computer B has clock cycle time of 500 picosecond, remember it, clock cycle time, and CPI of 1.2 for same program. That means our average instructions, average clocks per instruction is to 1.2. Okay, so don't come to any opinion because of CPI. So here clocks per instruction is 2.0, clock cycles per instruction 1.2. Then don't say that sir B is faster. We don't know, because sometimes, because to maintain this clock cycles per instruction, maybe that program might require lot of instructions, right? We don't know anything. Now we'll see remaining things. Which computer is faster for this program is the question, right? Now you tell me what is the execution time. Execution time formula will apply for A first. Then after that we can find out the performance. If you know performance, we can know the fastness, right? That's why let me first calculate execution time. Execution time of A. How many instructions we have for a program, right? So here how many instructions we have, that is not changed. So let us assume that we have n instructions, n into, and each instruction execution time, number of instructions per a program n, each instruction execution time, average clock cycles per instruction is 2, right? And if you want to know the time, let me calculate this, using seconds. Otherwise let's keep it as it is, n into 2.0 cycles, right? Clock cycles, remember it. How many clock cycles are required to execute this program under computer A? N into 2.0 clock cycles. For computer B, same program, that's why same number of instructions, n into, then what is the CPI? 1.2, right? So the formula for execution time is n into 1.2 clock cycles. But here this clock cycle is different from this clock cycle, because in computer A clock cycle time is, that's why 250, here it is 500. Now let's see exact time. How much time computer A takes? Time in the seconds. N into 2.0 into, what is the time duration? 250 picoseconds. Let's multiply. Then you get answer in seconds. Now here n into 1.2 into clock cycle. Each clock cycle takes how much time? It is, I think, 500, right? Computer A has clock cycle 250, computer B has 250 picoseconds. Now finally you have complete measurements in the seconds. So A takes n into 2 into 250 picosecond, B takes n into 1.2 into 500 picoseconds. When you have execution times, we can find out what? Performance, right? Let us compare the performances. Performance of A by performance of B, if you want to know, then equal to execution time of B by execution time of A. Let us use this formula. What is execution time of B? N into 1.2 into 500 picoseconds. Let me write here 500 picosecond. Why I am dividing one by one? Because there is one variable called n. I would like to cancel it. Then here also n into, second thing, n into 2.0 into 250 picosecond, right? So now picoseconds will be cancelled. 250 to the 500. So 2 cancelled, n cancelled, then 1.2. That means performance of A equal to 1.2 into performance of B. See now, CPI is here less, but still A is faster, correct? Performance of A equal to 1.2 times performance of B. What is the reason? Because the clock cycle time. Here clock cycle time is only 250 picoseconds, but in B it is double. That's why what I want to say is, only CPI doesn't matter. What is important is CPI is important, at the same time clock cycle is also, clock time also important, right? How much duration we are fixing. Apart from that, how many instructions your program is taking. Here in both programs, the number of instructions are same. Sometimes what happens, so maybe one computer will have very small clock cycle, another computer will have lot of clock cycle time, but here maybe instructions takes Example for same program, there are two computers, P1 and P2, A and B. In computer A, though clock cycle time is less, maybe to implement this program you require 100 instructions. But in another computer B, because why we kept clock cycle long? Maybe to execute very long instructions at a time. Maybe this instruction set might be different. Here, this instruction set may be complex instruction set, CISC instruction set. Then relatively, here maybe you require to do same functionality, you might require only 20 instructions. Then you tell me, by just seeing the clock cycle time, can you decide which one is faster? No. Then sir, how to decide? Clock cycle time, number of instructions per a program, and CPI, right? All these parameters are at a time important, right? Without all of them, we can't decide anything. Only by seeing, what is my suggestion is, only by seeing CPI, don't decide. Only by seeing clock time, don't decide. Only by seeing number of instructions, don't decide. Example, in the problem, you know that A, B are two computers. Computer A, in that computer A, one program is taking 100 instructions, and computer B, another program, same program is taking 200 instructions. Don't say that A is better. Why? The reason is, maybe these 200 instructions are taking lesser time than 100 instructions. Okay, let me elaborate that point. What I want to say is, you have two computers A, B. Okay, now this computer, you are executing the same program, program P. So in this computer, so program P is using 200 instructions, same program is using 100 instructions. Now someone asks you which one is better, don't say B is better. Why sir? Maybe there is a possibility that this computer is implementing a different instruction set. This computer might be implementing a different instruction set. So what sir? Maybe because of the implementation, these 200 instructions, each instruction may be taking 2 clock cycles. Such a way machine might be designed. But this computer B, in that each instruction is taking on average only 1 clock cycle. That means CPI also matters. Okay, what I want to say is, let's say here CPI is only 1 clock cycle. Understand? Maybe here 3 clock cycles CPI. Assume that CPI is 3 clock cycles. Then what happens? Sorry, here let me give lesser number. Here CPI is 3 clock cycles per instruction, and here that means it is 3. Here CPI is only 1. Now you tell me, same problem, computer A, computer B. To execute one program, 200 instructions to be executed. To execute the same program, here 100 instructions only to be executed. Which one is faster? Then don't answer, ask more details. The one more detail you should know is, sir, what is the instruction execution time? That is important. So that's on average, each instruction requires 1 clock cycle. Here each instruction requires 3 clock cycles. Again, don't decide. Maybe this computer's clock cycle, this computer's clock cycle may not be same. That's why finally what I want to say is, to exactly answer this question, first compute the execution time. I will give you final thumb rule, that is, don't decide by seeing number of instructions, don't decide it by CPI, don't decide it by one more thing, clock cycle. You need all sometimes. That's why, sir, then how to decide, sir? Finally, simple, calculate the execution time in seconds. That is the ultimate rule. Without calculating execution time like this, we calculate the execution time here, don't decide anything. If you calculate the execution time, you don't require anything. Understand? So that is a thumb rule. Now let me summarize. Whenever any problem is given and someone asks you about performance of any computer, first of all calculate the execution time. So execution time depends on CPI, clock time, and number of instructions per a program. Everything matters. That's why first take everything, note it down, and calculate execution time. After that, another computer's execution time. Then you compare them. That will be the ultimate idea. Understand?